Hey everyone, and thank you for coming out. And for those of you online, thank you for tuning in to my presentation. As she said, I've been working for Martin County now for 19 years. And I really have a passion for habitat restoration. Since I came to the county, I've worked in so many different types of plant communities and different areas that trying to improve the health and diversity of these important natural areas that we have is very important and dear to me. So which brings us to the reason for my presentation today is I'm here to talk to you about seagrass restoration and the Martin County Seagrass Restoration Project. So just basics, why do we care? Well, our seagrass habitat is really the key to our biological diversity in our estuary environments. They're really the basis for our estuary food chains. And historically, there was about 71,000 acres of seagrass habitat up and down the Indian River Lagoon. So my particular talk really emphasizes the Martin County portion of that and our work in the Martin County portion. And what we see in Martin County is that we've had this period of decline. In 2010, we had all these great lush meadows, really thick in this area in particular on this map. This is just north of the St. Lucie Inlet here in Martin County. And at that point in time, we had just tremendous health to our seagrass habitat. However, one thing I'll say is that actually followed about 5 years of drought that we had in Martin County. So we had all that because we had good water quality, we had a lack of stormwater runoff. And then between 2010 and 2018, we just really had this decade of decline, where by the end of that season, we essentially had barren ground in areas that historically had thick, lush, healthy seagrass habitat. So why did this decline? Well, starting in around 2011, 2012, we entered in a period of higher rainfall. And higher rainfall really brought more issues with water quality and water quality influencing water clarity in particular. But one thing I want to emphasize here is the sediment chemistry issue as well, as we think is an important part of this equation. And we have this increased stormwater runoff from local basins as a big part of it. And this is, if you can see it, this is taken from Sanskrit Park. You see the water is kind of chalky, coffee, not what you would expect in a natural, healthy estuary. And in a lot of cases, it was due to just local stormwater basin runoff. However, I'm not trying to underestimate the impact of when Lake Okeechobee releases happen. When those releases happened, and there were several years of them, it was incredibly destructive. Dark, tannic, nutrient-enriched water had a major impact on our seagrass areas. Which brings us to where we are now. So county became more and more interested in seagrass restoration. We had these manatee mortality events. So I started working on seagrass restoration. But to me, I wanted to take more of a holistic approach. I wanted to really understand what's happening in the estuary, what conditions are occurring in our estuary that either lead to a decline in seagrass habitat and a loss in seagrass habitat. I wanted to look at both the water itself and what's happening in the water column, I'll bring this issue up again and again, but I also wanted to look at the issue of the sediments and what's happening below the ground, because let's face it, a lot of the seagrass is below the ground. So what's happening there that's causing this decline? And I really wanted to use that to try and develop some successful strategies for seagrass restoration and figure out a better way to do seagrass restoration, because really the success rate worldwide of seagrass restoration projects is somewhere around 25 to 30%. It's very low. Which brings us to where I'm here today. So we're directing all these resources to seagrass restoration, and we're doing planting projects, and we're doing nursery capacity, but we're not really looking at the underlying issues that caused the decline in habitat in the first place. And I'm not saying this from a perspective where I'm against seagrass plantings. I'm saying that we don't have a full understanding of this issue, and that any seagrass planting project should be a part of a larger look at trying to develop a better and more healthier system for the seagrass. So our focal area is, once again, this area near the St. Lucie Inlet. So the St. Lucie Inlet is there on the towards the bottom right. And the reason why this area was selected is because of historically, that's where we had our best meadows. Our healthiest seagrass meadows were tended to be in this area. And part of the reason why is you have excellent tidal flushing in that area. So you have lots of oceanic, clear, good water coming into the area to keep light attenuation better. But we also had shallow depths, which, that's a big part of the reason why those meadows were so healthy. You have a lot of areas where the elevations are between 1.5 feet and 3 feet deep, really good areas to have healthy seagrass meadows. So it's interesting. I've actually been working on this project for 2 years, and I haven't planted a seagrass yet. So the first year was just really planning and starting to think about it and what's going on here. And then in year 2, so it says year 1, but really in year 2, we focused on research and monitoring. So we started by putting water quality sampling areas out there that took every 15 minutes would take recordings of different variables in the lagoon. And we also started looking at pore water. So pore water is like the interstitial space in the sediments. And you can look at different chemistry aspects to see what's going on in the soil. So we put out sampling areas for that. We also looked at a harmful algal bloom. And I know in the Northern Lagoon, you have a different, more of a pelagic issue, but we have more like a benthic. It's called Lingum. It's a cyanobacteria, and it has a very close association with our seagrass habitat. And we did extensive mapping and monitoring of the seagrass itself. And finally, at the bottom, we did Cbank analysis. So what's already out there? Do we not have any seeds? Are they gone? Are they still there? What kind of seagrass seeds are we finding in our estuary? So those are all kind of the questions that we wanted to answer in this last year. So for the water quality sampling, as I said, we were collecting every 15 minutes. We looked at nutrients. We looked at dissolved oxygen. We looked at light attenuation, so how much light was making it down to the plant layer, salinity, temperature, and then we wanted to compare that against our seagrass monitoring data. So we weren't just doing the water quality monitoring, we were also at the same time mapping and monitoring our seagrass health and plant cover. And then for pore water sampling, as I said, water clarity is probably the biggest issue in terms of seagrass decline. However, you cannot underestimate, the importance of what's happening in the sediments and how that's playing a role in this issue. So we looked at things like dissolved oxygen, hydrogen sulfide, and nutrient enrichment in the soils to try and paint a more full picture of what's happening. Whoops, skipped. And finally, this cyanobacteria I mentioned called Lingum. It seems to really it's not in all the areas where you have seagrasses, but in the Martin County areas, and especially these important meadows that I discussed, it's very prevalent. And it has a habit of carpeting these seagrass meadows. So that top center picture is a picture of a seagrass meadow. You can see kind of the seagrass underneath it, but it's just blanketed in this Lingum. It's just covering and carpeting these seagrass meadows. So what that causes is, one, we know it's decreasing light. So it's decreasing the amount of light that can penetrate and get back down to the seagrass, which needs that light to photosynthesize. But we're also starting to think that the Lingum has a role in changing and robbing the sediments of oxygen. So it's creating these anoxic soil conditions, and that double whammy seems to be particularly problematic with the seagrass. Not only that, but it'll fill up with air and become buoyant. And that bottom right picture, it's kind of a little hard to see, but there's all kinds of little seagrass mixed in with that Lingua. So it's like uprooting it, it's pulling it up, it's breaking it off. So it's also causing problems for the seagrass in that way. And that's kind of what it looks like when you pull it up. It just looks like brown goo. It's just, I don't know, I'm assuming some of you are familiar with it, but it's just this disgusting, kind of nasty looking stuff. And it's all over our seagrass meadows. And we believe that there's a role of nutrient enrichment is what's causing these blooms. So we actually went out and did some mapping of it. This mapping was completed in June, and it just goes to show you that it's throughout most of this one area that we looked at. So this was the primary area. It's 100 acres where we mapped seagrasses and we mapped Lingua. In this case, it was really just starting to come in. So the percentages were low, like less than 5%, 5 to 25%. 2 months later, this was like 80%, 90% Lingua cover. And we even experimented with doing some removal, and we did experimental plots. So we went in and we set up these plots, these quadrated areas, and we used like a little vacuum dredge operation. And that's Patrick Zoluego, our brilliant research scientist, who's kind of my partner in crime on this. We went in and with his hand, he would kind of gently rake it. And then he had this vacuum operation that would kind of suck it off the plants. But we wanted to compare that. So how seagrass would look in those areas where we were removing the Lingua with areas where we didn't, to see what kind of impact that it's having on our seagrass plant community. And we also were looking at, okay, like if we do this, is there a methodology we would need to actually remove it in areas where it was problematic? So at the same time, we were looking at seagrass monitoring and mapping. So we were looking at species composition. We were looking at what types of, what our coverage was. And how dense the seagrass was. And we looked at it in 3 different areas. So we have one deep water area, which was about 4 to 5 feet deep. And then we had 2 shallower areas that were spread out in different locations, so that we could get an idea of how seagrass was performing in the different areas. And then we mapped the seagrass, just like we did the Lingua. So this is a map. It shows the species composition. We actually found 4 different types of seagrass in this area. Primarily, it was shoalgrass and Johnson's, but there was some syringonium, some turtle grass, and there was a little bit of thalassia that was coming in as well. So we had those 4 species throughout the area, and we also looked at what the percent coverage of each of those species was. So one thing I want to talk about, right? I mentioned we had this period of decline. We had this 10-year period where seagrass just went from everything to nothing almost in our area. But a very interesting thing happened in 2022. So this is when I was just starting to get into this. I was just starting to wade into this project. We started to see this rebound and this recovery. And what happened is we had this early wet season drought that really went between June and August of 2022. And this crazy thing happened. We started seeing seagrass everywhere. And so me and Patrick, we're out there, we're trying to figure out, okay, where are we going to plant seagrasses? So if we did it in 2020, it would have been like, oh, we put it everywhere. But we're coming along in 2022 and we're like, there's seagrass everywhere. I don't know where we're supposed to do a planting project as a part of this, but there's seagrass in the places where we were going to plant. So, what are we even going to do and how are we going to do it? So you had this period of improved water quality because you don't have stormwater runoff, because you're having less rain in the time of season when seagrass is really getting started and expanding. So that tells us something. It tells us that, the seagrass it's really still there. it just needs a chance. It just needs the right conditions, and then it'll come back on its own, and it'll do it fast. You know, this was like in 3 months, it went from nothing to like this type of plant coverage, just like that. But however, that being said, by October of that year, it had to die off and was gone for the most part and went back to being very sparse. And there's certainly a seasonality for seagrass plants. You know, they tend to do better in the summer. But in this case, we had, I guess it was Hurricane Dorian that hit the West Coast. We had bad conditions over here on our side. You had poor water quality, and the seagrass didn't last through the end of that rainy season. But it really does give us hope. So that takes us to the studies that we're doing. And you know, I'll be honest here. When I originally agreed to do this presentation, I thought we would have more data than we do. We are, and I'm going to go through some pretty interesting results we're starting to see, but we're just starting to get these results in. So in like 3 or 4 months, we're going to have a lot more of this water quality data analyzed, and we're going to be able to do these comparisons. So, but one thing we did do is we did the Cbank analysis, which really is an understudied area in the Indian River, in the Indian River Lagoon. People haven't really looked and seen, well, what's already out there. So we went and we did little plots and took sediment cores from the area to see if the seagrass is still there. And I picked this because the image on the right shows this barren soil area. But then 6 months later, you come back and there's little shoal grass that was sprouting up everywhere. So to me, that meant that there's still seeds there. There's still something that's allowing these seagrasses to grow, at least in our area. And we found seeds. So we went in, we did this analysis, and these are little shoal grass seeds in this plot. And we found 3 different species. We found Syringodium, we found Haliduli, and Halophilia. So Johnson's grass, shoal grass, and turtle grass. I always get turtle grass and manatee grass confused. So we found them in the majority of these test cores, but now it's created new questions. So, okay, we have all these seeds, right? How many of them are there? Is there a difference spatially between how many we find in different locations? But more importantly than that even, how does that compare to a healthy meadow? So if we had great seagrass habitat, how many seeds would we expect to find in the sediments versus how many we did find? And that's something we're just starting to try and figure out. And it's hard because you want to look in the local estuary, right? You want to do this because of every portion of the estuary is different. You would have different sea levels based on where you are. But we don't really have healthy seagrass meadows. So where do we then look to find out, you know, what it would be like if we had a healthy meadow? And now we're starting to connect the dots. So we're starting to look at our seagrass indicators like rainfall, the water clarity, nutrient levels, nitrogen, phosphorus. We're looking at levels of dissolved oxygen, both in the water and in the soils. We're looking at the linga levels and how much it's found in the different areas. We're looking at hydrogen sulfide in the sediments, temperature. So we have all this data set that's been collected, and over time, we're going to parse through it and we hope to be able to better determine what relationships are occurring. But I did want to point this out. So this shows our seagrass monitoring that was completed in the last year. We had 3 different areas. So the different lines represent different areas. The light green one is our deep water area that we're doing monitoring. And so you're going to have less seagrass overall. But look at this trend. So we started this in 2023. We did our first monitoring events in March, and we had this little bit of sparse seagrass, so around 10% plant coverage. And then watch it jump. By May, it's up to 30%. And then by June, it was up to 60% in one of our research plots. So what you would really expect based on this graph is that it would keep going, right? It would just keep going up. If we went back in August or July, you would expect that it would be 90%, maybe even 100%. And it would just keep getting thicker and healthier and denser, really through the end of the summer growing season of October. We should have had really great, nice, healthy meadows. And one thing I'll point out, we had an issue. We weren't able to do our monitoring in July, which is unfortunate because it looks like something happened between June and August. All of a sudden, out of nowhere, the seagrass started to decline. Went back down to 40% by August when it should have been 90%. And it continued to decline throughout the remainder of the year. But one thing I'll note, so I took this picture of our seagrass meadows in early August. So I went out there and I looked, and look at how much Lingby is on there, just carpeting and covering those areas. And if you look closely, it's hard to see on that, most of the seagrass on there is dead. It died off. Something happened between June and August that we had this big die off. And if you look even closer, you would have seen there are like seagrass starting to pop back up in that area. So there's little seagrasses starting to come up throughout that area. But you just can't see it on this photo. So we really want to understand this trend. What happened here? What event happened? How did it cause this reversal of what was looking like a really good seagrass year to occur? And you can see, like, if you look at that photo too closely, you can see all the old, like it's dead, but some really thick, healthy, lush seagrass was in there before we had this die off. So we were also doing this experiment on the cyanobacteria. And I mentioned we were removing the cyanobacteria. So we would go in, remove the cyanobacteria from our target plot areas, and then we would monitor the seagrass. And we compare that versus an area where we didn't remove the Lingua and see what kind of correlations we could happen. But some interesting things to point out here. We did find that the cyanobacteria, it's very interesting. It declined between May and June, but then look what it did in August. Look at how prevalent it was in August. So between June and August, this major bloom happened. And it didn't matter that we were out there in June, because by August, the amount of that Lingua between our treatment area and the area we did nothing was the same. So this massive bloom happened, and the frequency that we were doing the Lingua wasn't frequent enough to really capture and do anything about it when that happened. Now, the Lingua also started to come in during the month of May, is when it really started to come out. And Patrick, the research scientist that I mentioned, thinks that what tends to happen is you have a big rain, when you start to get big rain events, you get this flush of nutrients into the system. And that's what's fueling, and temperature is a part of it too, but temperature, but then also these nutrients are creating these big increase events in cyanobacteria. So this maps we have control versus treatment, right? So the control areas are the area where we didn't do any Lingua removal, and the treatment areas are where we did Lingua removal. And this is mapping seagrass in those areas. So we did, it's very interesting. In June, we did not find the results we were expecting. It actually didn't matter if the Lingua was there or not. But if you look, there was actually less Lingua at that time. So it decreased between May and June, the Lingua levels. So, but in all the others, there seems to be a positive relationship, albeit small, between the seagrass percentage and the amount of Lingua in these areas. But it was shown to be statistically significant as an 18% increase in seagrass if the Lingua was there. And what we think is happening is that we're not removing the Lingua frequently enough, that comes in too quickly, so we're not capturing the impact that it's having on the grasses. So this are our three different areas. And one thing I wanted to point out from this is that you can really see the green line, the lines on the bottom, the greens, those are seagrass percent covers. So that's really showing how healthy our seagrass meadows are. Whereas the brown shows the cyanobacteria coverage. And if you look, especially on the shallow water sites, there's a huge relationship, it seems, between the cyanobacteria and the level of seagrass coverage. So once again, and we don't know for sure because we still need to look at our water quality variables. We still need to look at all those other indicators, but we really think that the seagrass die-off happened as a result of this Lingua. So I want to talk about another aspect of the project that we're working on. In 2022, I actually went to a conference up in Annapolis, Maryland. And one of the presenters there was Dr. Diana Chin. She worked at with the University of Florida at the time, who had done her research on the species of clam. And she had completed this research and done some mesocosm studies. And she found that these clams, and it's a species of a family of clams, that they had a positive effect on seagrass. And so what these clams do is they live in the sediments, and they have a symbiote, like a bacteria that lives in their gills. And this bacteria uses hydrogen sulfide to power their cellular reactions. And then, and in doing so, they actually have this role in helping to remove hydrogen sulfide and oxygenize the soil. And her theory was that when you get these seagrasses and they're under stress to begin with, mainly due to a lack of light, so the light's not penetrating as well as it should through the water column, so you get these stressed seagrasses, and they become more susceptible to hydrogen sulfide that's in the sediments. And her theory is that the hydrogen sulfide is really then what's killing these seagrasses off. So that combination of the two is what's really destroying these seagrasses. And she proved that with her experiments. There's a lot going on in this chart, but in the presence of clams, so we're looking at the chart on the left, you'll see when clams are present, a much higher survival rate and density of seagrass than in their absence, especially under poorly lit circumstances. And she took it further and looked at hydrogen sulfide in the sediments and these different variables, ammonia and phosphorus, and found that they were really drawing down those levels. So oxygenizing the soil, and it was removing a stress factor from the seagrass. So her theory was that we should be considering using this family in conjunction with our seagrass projects. So the first thing we wanted to do is we want to say, okay, are they there in our estuary? So we brought Dr. Chin down for a visit. And it's funny because we met with her on a Zoom call initially, right? And so we're sitting there talking, and she's like, you guys don't understand. When I find these clams, the dopamine hit is real. So she says that. And so we go out and we're doing our monitoring, and we find, they're called diva lingas. So we find this species of leucinate clams. And then there's Dr. Chin on the right, beaming because of the dopamine hit from finding all these guys. So it's a cool story, but it's interesting because they really haven't been commercially spawned before. You know, there are clam operations throughout the state, but most of them are looking at hard clams like Mercenaria that use algae to power their reactions. So these guys are a little different. And if we want to use them in our restoration projects, you can't just go grab a handful and toss them somewhere else. You have to be able to commercially grow them. You have to be able to use them at a large scale. We're talking millions of them. So I'm partnering at Florida Oceanographic Society. There's a clam growing operation, Great Florida Shellfish Company. And we're partnering with them, and they're building a special facility just to try and grow these clams. so that one, we can run more experiments on them, and two, we can include them in our seagrass restoration project. Which brings us to where we are now. I said, we're actually doing a planting project as a part of this project. I'm not against planting, but I think it should be a part of a bigger picture. So we are planning on doing a planting project in the upcoming year, but we're not going to do just one planting. We want to do multiple plantings across different seasons to see if seasons play a role in how well these seagrass restoration projects do. We want to continue working on the cyanobacteria removal research. Like, we really need to understand this better and figure out better, are there some different ways that we can remove it? I want to see, can we get it in a mesocosm area so we can really focus on the area and treat it frequently enough so we can really pin down the effect that it's having on our seagrasses. We want to try and include these clams. If we're successful at the spawning operation and it works, let's bring them out there. Let's put them out there and let's see how these seagrass areas respond if you include the clams with it. And we'll also experiment with herbivore exclusion devices. Our source is going to be Florida Oceanographic Society. They're actually expanding. They have an existing seagrass facility there. They're actually expanding it. They have this game fish lagoon, and a part of it they have turned into a seagrass meadow. And that'll be the borrow site that we'll use for our project. Oh, and shoalgrass will be the primary species. And that's it.
Thank you so much.
Yeah.
All right, we're going to get started from some questions from Zoom while I come around and collect any questions that we have out here. The first question is, what is the source of the seagrass seeds that you found? Have you done any DNA testing?
So as I said, as time goes on, we'll be able to get more data. Right now, all we have is we sent it back for analysis and we found that the seeds actually do exist. We're now just figuring out what questions we're gonna have. So potentially we could look at DNA sourcing. We could look at, we're gonna create hot maps and see the differential between where it's found versus not found. We'll, trying to understand what would a healthy meadow look like. So we have some point of reference, because I don't know, we don't know what this actually means. We just know that there are actually seeds out there. And that's still important because of, now we know that seeds are a driving force in our restoration and recovery. Another thing we need to look at, which we haven't done yet, is the below ground biomass of the seagrass surviving? So is it just being top killed, but then when the conditions are right, does it grow back up? So it was interesting, when we were doing our clam work, and you basically go out there and you dig and you do cores and you look for the clams. I could find rhizomes of seagrass in there, live rhizomes, and this would have been last December when there's very little seagrass actually out there. So some of it is most likely overwintering and surviving and then coming back the next year. But how do we analyze that? How do we assess that? How do we determine, how much of what's coming back is from the rhizomes versus the seeds versus floating plants, hitting the ground somewhere and then sprouting from that way? That's a question. That's some of the questions we still have.
Our next question here is, are you able to incorporate tracers to determine the source of the contaminants?
That's a great question. And yes, and I should have brought that up in our project. I've actually been talking with Brian LaPointe from Harbor Branch, and we're very interested in looking at the nutrient contents of both the cyanobacteria and the linga, or the cyanobacteria and the seagrass, but also potentially doing some source tracking because of, is this coming from a septic system source? Is that nutrient fueling these plants? Is it just fertilizer and stormwater runoff? We want to run all those analysis and try to be able to figure that out.
Right. Did you look at organics in the sediment and/or water column?
We have not really looked at organics at this point. So,
And then we have a couple questions about herbicides. Are you able to monitor herbicides?
I'm going to be honest. I'm not really, there's other people, if they're looking at herbicides, that's fine. But my take on this, like the one thing I bring up, right? So there are two instances of improved seagrass success. One is Chesapeake area and one is Tampa. There's been an increase in seagrass in the Tampa area over time. They had a little bit of a die off, but they've had issues with water quality as well with the hurricane and storms. My take is that I don't believe that herbicides are the driving force behind the seagrass decline. I mean, you look at it, light availability is huge. It's crucial. Like it's there, it's right on the surface, it's apparent. We know that there's anoxic conditions in the soils. And based on Dr. Chin's research, you can see that hydrogen sulfide also negatively affects these seagrass. To me, it's just staring me in the face as those two being the driving forces. And I don't believe that herbicide is causing this decline. As I said, if somebody provides some research, like there's other people out there looking at all these things, if somebody shows me here, like here's some research that shows in the presence of herbicides, we're seeing this decline, then I'll take that into account. I just don't see it at this point.
All right. Our next question is, houses are being built on the lagoon and destroying the natural coastline. They use fertilizer and pesticides directly on land adjacent to the river. How is this allowed?
I'm not a regulatory person, I can't say, it does show the importance of having shoreline protection zones and native habitat on your shoreline. Absolutely 100% makes a difference.
Thank you. Did you find a link between Lingua and hydrogen sulfide? And this also says, side note, the tryptin levels, suspended solids never seems to divide in the July time period. Did I read that correctly? Decline in the July time period.
So, all right. So starting, we haven't linked it yet. However, that being said, so Patrick, when he was out doing his cyanobacteria removal, he noticed something interesting. When he would go through and remove the Lingua from the area, he noticed that the sediments were black underneath, which is an indicator of, high sulfide concentrations and anoxic conditions. So we haven't definitively linked it, but it's another area where we can work to show that role. And the mesocosm will help as well.
The Lingua blobs and ending up on the shoreline, it's a strong salt percent.
Yes. Yeah, 100%. I am confident. And like I said, that's the preliminary results. It's really just qualitative that Patrick provided. Now we're doing pore water. So it is possible that from that pore water analysis, like if we sample from an area with Lingua and we find a similar area without it, and you measure those hydrogen sulfide concentrations, then it's possible we can really create a quantitative, definitive link between the two.
Can I ask a follow-up?
Sure.
When you're doing this forward analysis, you're doing it at the time that you removed the Lingua from the seagrass. You're not doing it 2 days, 3 days out. So
you're saying, yes.
So
I get what you're saying.
Yeah, what I would suggest is you do maybe a lab experiment with all of them.
Yeah, and that's why we want to do, like, there's so many different things that need to be tested with these Lingua, with Lingua, and it's hard to do it because there's so many other things that are happening in a lagoon. And logistically, if I were to do that, I would have to send Tetra Tech and Patrick back out a second time a few days later. So it adds a lot of expenses to do that. So if I can figure out, how do you even do it in a lab? How do you even do it in a mesocosm? How do you get it in there? Yeah, you can look at so many variables, and it's so much easier to do than having to do a separate monitoring trip just to do that. So certainly, but we are getting the water quality sampling, which will probably reconfigure the areas that we have our sampling stations, and can certainly include that in an area that we're doing the Lingua. So we do have water quality data, and that's going to be important. We just haven't broke it down yet. We haven't gotten the results back.
So the second observation of the question, during that drought period, residing curious whether they'll any Lingia as well.
Well, it's yes, and because the Lingua was definitely present back then. I remember, I've been going out since 2004 and looking at these areas, and for a while I was just doing it because I'd be out, at bird nesting island, so I'd be out there once a month, and I'd look, and hey, there's seagrasses and they're healthy, and there was Lingua there. So I think it's that. I think it's, the poor water quality. I don't want to say that poor water clarity and poor water quality are not playing a role. Brian LaPointe brought up that he brought up the role of fertilizers. In particular, he brought up nitrogen for fertilizer. So when you have very nutrient-enriched water, it increases the photosynthetic demand of the seagrasses. So they need more light in high nitrogen environments to survive. So there's all different complexities to this. But I would say, the take homes are still light, and then sediment and anoxic conditions, I think, are two of the biggest factors.
All right. Thank you for that. Our next question is, what is causing the hydrogen sulfide formation?
Well, the hydrogen sulfide is because of the lack of oxygen. So hydrogen sulfide it's a natural process. And in the absence of oxygen, it's how decomposition happens. The process creates hydrogen sulfide.
Gotcha. Do the different types of seagrasses live well together?
They tend to have different niches, certainly. So one of the associations, like Thalassia, is probably one of the more important seagrasses, but it's also the least tolerant. So what you tend to have is at the start of the season, you'll start by Johnson seagrass and shoalgrass will start coming in. And as it takes over and it'll kind of stabilize the sediments and builds up, then you'll start seeing more syringonium, the turtle grass, and you'll start seeing more Thalassia will come in. So they do coexist, and different ones will have different niches, and some will come in earlier and then will be replaced somewhat by Thalassia over time. So yes.
Awesome. What is the commercial value of the clams?
In this case, these clams, they're tiny, like they're the size of your pinky nail. You're not going to be going out and like, oh, look, I'm going to have a clam fry tonight, So the commercial value for this type of clam would be strictly for restoration benefits. Now, are there other kinds of those clams that could have commercial value just for being edible? That's possible. But another thing to mention about these clams, when we went out looking for them, they were like 18 inches to 2 feet down in the sediment. So they're not like in a regularly available space. They're kind of hard to get to. So I don't think they'll ever really have commercial value. And maybe there's a lucynid clam, lucynid as a family. Maybe there's lucynid somewhere in Southeast Asia that could be marketed for being edible. But the primary benefit here at least, will be just for using in restoration projects.
And then what are the water quality conditions for the clam survival?
Well, that's something we need to figure out. Obviously, they like salty water, right? We're finding them close to the inlet. These clams are found in association with seagrass. So that's actually important for them, that they grow in conjunction with seagrass. And they'll actually move and migrate to find where the hydrogen sulfide is. So you might put them in one area, they'll go down and they'll find that anoxic area and they'll be like, oh, this is great. Everyone else hates these conditions. This is perfect. Like, I think I'm going to hang out here. Did I answer that question? I think I did. Yeah. All right.
Do you have any insight into other seagrass planting efforts?
We're certainly looking at that. And there's a lot of so there are FWC, I believe, funded 6 nursery operations for seagrass to be used on the Indian River Lagoon. I know Brevard County is doing seagrass plantings. I've actually done, for my MC2 project, we actually did seagrass transplanting projects. So yes, I do follow along when I see these projects coming online. But also, I think to really see if a seagrass planting is successful, you're going to need 5 years of monitoring. Because I'm not going to, maybe in year 1, it looks great and it's growing everywhere. But this, in our area especially, we get lake releases. Any seagrass plantings we put in will be wiped out by a lake release. So there are, needs salty water. Is there temperature constraints? Probably. I don't really have that data yet.
Given that the sediment conditions affect the survival rate of adult plants, do you think it may also have an effect on the viability of the seeds themselves?
Hey, that's a great question and something for us to look at. Now, I will say that the seeds are there, right? So we had these bad events happening, but the seeds are still there. So my guess is that the seeds are surviving. And remember, hydrogen sulfide doesn't necessarily have to be bad for the seagrass. It's when you combine the poor water clarity and then the anoxic conditions creating high hydrogen sulfide levels, that's what seems to be finishing the seagrass off.
All right, and then we have one more question here. I saved it for last. Could you use any volunteers in your project? Tell us what you need.
We're still developing the project, so it's something we could certainly look at. Maybe even if we get these clams going, somebody, we could use volunteers to help spread them. So right now it's hard to say, but I'll let MRC know if I ever need volunteers for this.
Thank you. And then if people do want to get in contact with you, what's the best way to reach you?
Email or is fine. So.
Okay, beautiful. Thank you so much. And let's give them a big round of applause.